4 minutes ago, data arrived from the edge of the solar system that has stopped a room full of scientists cold. Voyager, the spacecraft that humanity launched into the void nearly 5 decades ago, has just sent back something that nobody expected. Not a routine telemetry packet, not a scheduled instrument reading, something in the data that the engineers at NASA's Jet Propulsion Laboratory are still staring at right now, running calculations, checking their instruments, and coming up empty, because what Voyager detected is moving. Something out there, in the darkest and most remote region our spacecraft has ever reached, is in motion, and it is not a planet. It is not a comet. It does not match any known object in any catalog that astronomers have built across centuries of observation. It is something else. And right now, nobody can tell you what. Before you can understand why this detection has silenced a room of some of the most experienced deep space engineers alive, you need to understand where Voyager actually is and why detecting anything at all from that location is extraordinary. Voyager was launched in 1977. It has been traveling continuously ever since, at a speed of approximately 61,000 kilometers per hour. At that pace, it has covered a distance that is almost impossible to picture. Right now, Voyager is more than 24 billion kilometers from Earth. The light that left our planet today will not reach Voyager for over 22 hours. When Voyager sends a signal back to us, that signal travels at the speed of light and still takes nearly a full day to arrive. Nothing built by human hands has ever been this far from home. Nothing ever will be, for generations. Voyager is the absolute frontier of human reach, a machine the size of a small car, drifting alone through interstellar space, powered by a system that generates less electricity than a household light bulb. And from that impossible distance, it just sent back data describing something it cannot identify. The interstellar medium, the region of space Voyager entered in 2012, is not empty. It is filled with a thin soup of charged particles, magnetic fields, cosmic dust, and radiation streaming from distant stars. Scientists had been studying this environment for decades before Voyager crossed into it, building models of what the probe would find on the other side of the heliopause, the boundary where our sun's influence ends. Those models were wrong. Not completely wrong, but wrong enough to matter. The density of the interstellar medium was different from what had been predicted. The magnetic field was oriented in an unexpected direction. The behavior of plasma, the charged gas that fills the space between stars, did not match the equations that physicists had spent decades refining. Voyager has been sending back data that challenges our models of interstellar space for over a decade. Scientists have incorporated that data, updated their equations, and built better models. It has been the scientific process working exactly as it should: observe, revise, learn. But what arrived 4 minutes ago is not a refinement to existing models. It is something that the current models have no category for, something that the updated equations, the revised predictions, the improved understanding of interstellar space that Voyager itself made possible, none of it predicted this. To be precise about what was detected, you need to understand what Voyager's instruments actually measure. Voyager carries several scientific instruments that have survived the journey from Earth to interstellar space. The Plasma Wave Science Instrument detects waves in the charged particles surrounding the spacecraft. The magnetometer measures the strength and direction of magnetic fields. The Low Inner counts individual particles arriving from various directions. And the Cosmic Ray Subsystem tracks high-energy particles originating from outside our solar system. Together, these instruments paint a picture of the environment Voyager is moving through. Scientists read that picture every day, logging the data, looking for patterns, updating their understanding of what interstellar space is actually like. 4 minutes ago, multiple instruments registered a simultaneous anomaly. Not one instrument producing a glitch. Not a single sensor giving an unexpected reading that might be explained by hardware degradation after 47 years in space. Multiple instruments measuring different physical phenomena, all registering something at the same location and the same time. The plasma wave data showed a disturbance in the charged particles surrounding Voyager, a ripple pattern that engineers describe as consistent with something displacing the local medium. The magnetometer showed a corresponding shift in the magnetic field in that region, and the cosmic ray subsystem registered a change in the directional distribution of incoming particles, as if something had created a shadow blocking particles from one particular direction. 3 independent instruments, 3 simultaneous anomalies, all pointing to the same location in space relative to Voyager's position. Something is there, and it appears to be moving. The first hypothesis that engineers test when Voyager sends back unexpected data is hardware failure. After 47 years of operation in an environment flooded with radiation, the spacecraft's components have degraded beyond any designed lifespan. Memory chips have developed faults. Circuits that were meant to last 5 years have been running for nearly 50. Cosmic rays have bombarded the electronics billions of times, occasionally flipping bits in the computer memory and causing the spacecraft to produce garbled output. Hardware failure was the first explanation considered for today's anomaly. It was ruled out within hours. The reason hardware failure does not explain this is the correlation between instruments. When a sensor fails, it fails in isolation. The plasma wave instrument might produce noise, but that noise does not simultaneously appear in the magnetometer data. The cosmic ray detector might register a spurious spike, but that spike does not produce a corresponding shadow pattern in the particle distribution that the low-energy detector sees. The 3 anomalies are correlated in both space and time. They point to the same source. They arrive simultaneously, and the pattern they form, the ripple in the plasma, the shift in the magnetic field, the shadow in the cosmic ray distribution, is physically coherent. It describes something consistent with an actual object moving through the interstellar medium in a specific direction at a specific speed. Hardware does not fail in a way that mimics the signature of a moving object across 3 independent measurement systems simultaneously. This is not a sensor glitch. The data is real. Something out there produced it. The second hypothesis, once hardware failure is eliminated, is a natural astrophysical phenomenon that has not previously been observed in this region of space. There are phenomena that can create disturbances in the interstellar medium. A shock wave from a distant stellar explosion could, in principle, ripple through the medium and produce patterns in the data. A dense filament of interstellar gas, the kind that astronomers observe in other regions of our galaxy, could create a local concentration of material that displaces the surrounding medium as it moves through space. Scientists at JPL have run the data against models of these known phenomena. None of them fit cleanly. A shock wave from a stellar explosion would produce a characteristic pattern, a sharp leading edge followed by a gradual dissipation. What Voyager detected does not have that profile. The disturbance is localized. It has defined edges. It does not spread and dissipate the way a shock wave does. It is compact, coherent, and moving in a direction that does not correspond to any known energetic event in the surrounding region of space. But it was still unmistakably interstellar in origin. 3I/Atlas, detected more recently, became the third. The existence of interstellar objects passing through our solar system is now established science. Objects from other star systems do travel through the space between stars. Some of them pass close enough to our sun to be detected. What Voyager may have just found is something different from all of those. Not an object passing through the inner solar system, where telescopes can see it, but something drifting through interstellar space itself, far beyond the edge of our solar system, in a region that no instrument other than Voyager has ever been close enough to measure directly. If the data holds up, if further analysis confirms that what the instruments detected is a real, bounded moving object, then Voyager may have just made the first direct detection of an interstellar object from interstellar space itself, not observed remotely through a telescope, detected in situ by a spacecraft physically passing near enough to measure its effect on the surrounding medium. That would be unprecedented. That would be historic. That would be something that no mission in the history of space exploration has ever achieved. The challenge now is verification. Voyager cannot turn around and look at what it detected. It has no camera that could resolve an object at the distances involved. It cannot stop and conduct a closer investigation. It is moving at 61,000 kilometers per hour and has no way to slow down, change course, or return to the location where the anomaly was detected. What scientists can do is analyze the data with extreme care. They can model what kind of object would produce the exact pattern of disturbances that Voyager recorded, working backward from the instrument readings to constrain the size, mass, and velocity of whatever created the signature. They can look for any corroborating data from other sources, ground-based observatories that might be able to search the region of space in question, satellite instruments that might detect something consistent with the Voyager anomaly. And they can wait for more data. Voyager continues to transmit daily. If the object is large enough and moving slowly enough relative to Voyager, it may still be in the vicinity of the spacecraft's instrument range. Subsequent transmissions in the next 44 to 88 hours might either show the signature fading as Voyager moves away, or continuing to evolve as the object and the spacecraft remain in proximity. Each 44-hour round trip, 22 hours for a command to reach Voyager, 22 hours for the response to return, is a new chapter in this investigation. The next transmission is already being anticipated by every scientist who has seen today's data. Take a moment to sit with the scale of what is happening. A machine built by human beings in the 1970s, running on less power than a light bulb, traveling through interstellar space at a speed that would take it 40,000 years to reach the nearest star. That machine has just potentially detected something that no instrument in human history has ever directly encountered, not through a telescope, from a safe distance, looking at reflected light, directly in the physical environment, using sensors that measure the actual plasma and magnetic fields and particle distributions in the space immediately surrounding the spacecraft. If you want a measure of how remarkable this is, consider that Voyager was designed to study Jupiter and Saturn. Its primary mission was complete within 5 years of launch. Everything that has happened since, the crossing into interstellar space, the measurements of the heliopause, the ongoing transmission of data from beyond the edge of the solar system, all of it is a bonus. All of it is the spacecraft continuing to do science that nobody in 1977 could have imagined it would still be capable of doing. And today, at the very end of its operational life, with power levels dropping every year, instruments being shut off one by one to conserve the remaining electricity, a transmission window that is narrowing as its power supply approaches the threshold below which communication becomes impossible. Voyager may have just made the most significant detection of its entire mission. Scientists will be cautious. They will be methodical. They will not announce anything until the data has been verified through every available means. The history of science is full of anomalies that turned out to have mundane explanations, and every researcher who works on this investigation knows that the most likely outcome is an explanation that involves known physics, even if it is physics being expressed in a way nobody has seen before in this context. But they will also be honest about what the data shows, and what it shows right now, today, 4 minutes ago when the signal arrived, is something moving in interstellar space near Voyager, producing a coherent signature across 3 independent instruments in a pattern that does not match any known natural phenomenon that has been modeled for this environment. It is a question, an extraordinary, unprecedented, genuinely mysterious question, being asked by a 47-year-old spacecraft from the edge of everything we have ever explored. The answer is not yet known. The investigation is ongoing. The next transmission is 22 hours away. And somewhere out there, in the cold darkness between stars, something is moving through the same region of space where humanity's most distant traveler is quietly measuring, recording, and sending its findings home, one signal at a time, across a silence so vast that the signal itself takes nearly a day to cross it. 5. We built something and we sent it as far as it could go, and from the edge of everything we have ever known, it just told us that we are not as alone in that darkness as we thought. Consider for a moment the people who are sitting with this data right now. The Voyager mission team at JPL is one of the longest running groups in the history of space exploration. Some of the engineers and scientists who work on this mission today have been with it for decades. They have watched this spacecraft grow from a newly launched probe studying the outer planets to the most distant human-made object in existence. They have celebrated milestones that no one expected to reach. They have solved problems on a machine 24 billion kilometers away, using tools and techniques that were invented long after the spacecraft was built. These are not people who are easily surprised. They have seen Voyager do remarkable things. They have received unexpected data before and worked through it methodically until an explanation emerged. But the scientists reviewing today's transmission are doing something different. They are not running the standard diagnostic checks. They are calling colleagues. They are pulling in researchers from adjacent fields, plasma physicists, magnetospheric scientists, astronomers who study interstellar objects. They are doing what scientists do when something genuinely new has arrived. They are making sure they are not missing anything, not overlooking any known explanation before they let themselves sit with the weight of what the data might actually mean. That process takes time. It takes rigor. It takes the kind of careful, unhurried analysis that distinguishes science from speculation. But it also tells you something. When you look at the activity in that control room today, when scientists who have spent their careers building models of interstellar space are calling each other and talking quietly about what they are seeing, something real is happening. There is one more layer to this story that very few people will mention, and it deserves to be said clearly. Voyager's power is running out. The spacecraft is powered by radioisotope thermoelectric generators, devices that convert heat from the natural decay of plutonium into electricity. When Voyager launched in 1977, those generators were producing about 470 watts of power. Every year since, the plutonium has continued to decay, and the power output has continued to drop. Today, Voyager produces roughly 40 watts, less than a standard household light bulb. To conserve what remains, NASA has been shutting down instruments one by one. Heaters that kept components warm in the extreme cold of interstellar space have been turned off. Non-essential systems have been powered down. The mission team has been making difficult decisions about which instruments to keep running and which to sacrifice, because the power budget no longer allows everything to operate simultaneously. The instruments that detected today's anomaly, the plasma wave system, the magnetometer, the cosmic ray detector, are among those that have been prioritized. They are the eyes and ears that Voyager still has in interstellar space. They are the reason that today's detection was possible at all. Within the next year or two, the power will drop below the level needed to keep even these instruments operational. After that, Voyager will still be out there, still traveling, still moving deeper into interstellar space, carrying its golden record through the darkness for millions of years to come. But it will be silent. It will no longer be able to tell us what it finds, which means that today's anomaly, whatever it turns out to be, may be among the last great discoveries that Voyager makes before it goes quiet forever. One of the final transmissions from the most distant explorer humanity has ever launched. A mystery delivered from the edge of everything we have built, in the closing hours of a mission that has already exceeded every expectation anyone ever had for it. There is something deeply human about this moment, if you allow yourself to think about it. In 1977, a team of engineers and scientists built a machine and put it on a rocket and launched it into space. They were doing their jobs. They were doing science. But they were also doing something that every generation of explorers has done. They were reaching as far as they could reach, trying to see as far as they could see, pushing the boundary of the known world just a little further into the unknown. They attached a golden record to that machine, filled with music and voices and images, because they wanted to believe that reaching was worth something, that the universe might have something in it worth reaching toward. For 47 years, Voyager has been traveling. For 47 years, it has been sending back data. It has given us knowledge that we could not have obtained any other way. It has told us things about the edge of our solar system and about the interstellar medium beyond it that have rewritten textbooks and challenged theories and expanded our understanding of the cosmos in ways that nobody in 1977 could have fully predicted. For 47 years, Voyager has been traveling. For 47 years, it has been sending back data. It has given us knowledge that we could not have obtained any other way. It has told us things about the edge of our solar system and about the interstellar medium beyond it that have rewritten textbooks and challenged theories and expanded our understanding of the cosmos in ways that nobody in 1977 could have fully predicted. And 4 minutes ago, from the greatest distance any human-made object has ever traveled, it sent back one more piece of data, one more observation, one more signal from the frontier. Something is moving out there. Something that the best models, the best instruments, the best minds working on deep space science cannot yet categorize or explain. Maybe it will turn out to be something simple, a known phenomenon appearing in an unexpected configuration, a natural process that existing physics can describe once the analysis is complete. Or maybe it will turn out to be something else, something that requires a new explanation, something that expands the framework rather than fitting neatly inside it. Either way, the data is real. The signal arrived. Voyager found something in the darkness between stars that we did not know was there. And for now, in this moment, before the analysis is complete and the explanation is known, we are in the most honest place that science ever reaches. The place where the data has arrived and the answer has not yet caught up to it. Something is moving in deep space near Voyager. Scientists have no explanation. The investigation has just begun.